All right, so today's session is about advanced sales conversations. And really what we're talking about is, in a lot of the sales calls that we're on, the people that we're talking about are asking for things like, tell me about how you're migrating to cloud. Tell me about how you're making your organization more efficient. So ultimately, these are the strategic drivers for many of our customers' businesses. And we're going to talk about how we can insert ourselves into some of these conversations and ultimately drive value. So specifically what we're talking about is talking about the largest technology trends today and how to leverage these within our conversations, and ultimately the difference between pitching products and solutions. So have you heard of the difference between product sales versus solution selling?
Have.
Okay, cool. So just go over that real quick then. So when you sell products at a very high level, people are asking things like, hey, can it do this? Can it do this? Oh, this one is $1 more. Well, basically, it's a conversation about functionality and price, right? Contrast that with selling solutions, and then all of a sudden you have now multi-year commitments that are a much higher dollar value. So if you think about the difference between selling like a gym membership versus selling like a health and wellness system, which would include training, your gym membership, also videos, also like dietary stuff that you get shipped to your door. So what the research has found is that in our current time, solution selling is way more effective for complicated customer problems. And the reason why this is good for us is because technology in general is very complicated. It's not really so much about like, hey, we're looking for one tool. Can it do this? Can it do this? It's talking about how can I pivot my business so that I can have strategic advantages over my competitors. The reason why all this stuff matters is because all of the technological things that businesses are investing in, they basically play into this, right? So the reason why businesses are migrating into the cloud, why they're investing in microservices and doing all this other stuff, is because they're trying to solve extremely complicated problems that will ultimately give them advantages. So at a high level, again, product sales, it's about capabilities and price. That's basically transactional. A lot of times you're going to have to offer discounts versus solution sales. It's usually a multi-year deal. It's usually something much more complicated. And once again, the research shows that for complicated customer problems, it's way more effective. So let's talk about the general methodology for solution selling. This is something that we hear a lot of the times on our sales calls, but the first thing is uncovering problems by asking questions. So I'm sure that you've heard what are some of the current initiatives in your organization. That's a really common one. But then ultimately presenting solutions and discussing proof points. So pivoting from here's what you're trying to do to here how we can help. Here's how GitLab can be a strategic partner for you to help you solve your long-term initiatives. And now all of a sudden you have a 3 to 5 year deal. Maybe it's ultimate, probably includes professional services and implementation. So versus if we get pivoted into a product sale, it's just, can we do this? Oh, GitHub does this. Give me a discount, right? So that's the big difference. So what are some of the current problems that we have for business executives right now? There's a bunch that are specific to an industry, but in general, across like the developed world right now, what we see is really 5 main issues. One is how to keep up with latest trends. Technology is always increasing, so how can we make sure that we have the latest and greatest stuff, which is a strategic driver for my business, right? If my business is doing something, if my competitor is doing something more efficiently than me, then over a 3-year time horizon, that's going to be a competitive advantage for them. Problem number 2 is how can we keep on deliver quality software on time? This is something that all businesses care about, while at the same time reducing cybersecurity risk and maintaining compliance. The last 2 ones is how do we develop and retain talent, and how can we make sure that costs are reasonable? So these are general business things, but when we are on these conversations and customers tell us, hey, we're migrating to the cloud, hey, we're investing in microservices and some of these other technological things, it's really important to understand that These tech changes that they are doing, they just fit into the larger business goals that they have. So the largest four technological initiatives that we have currently right now in the year 2021 is one, adopting a cloud strategy, cloud migrations. Basically, every single business that you talk to is thinking about or already has migrated things in the cloud. Number two is how do we adopt automation best practices? Ultimately, what this allows people to do is save time, money, energy, and allows them to basically become more efficient. Number three is adopting infrastructure as code. We'll talk about what GitOps is, but I'm sure that you've heard around, we'll explain exactly why people are trying to investigate things like infrastructure as code and what GitOps brings to the table. And the fourth one is really, really big. This is one that is going to be a strategic driver for many businesses and save many businesses maybe 20 to 30% in cost, is adopting containers or microservices across all of their applications. So we're talking about reducing your operational expenses by a significant margin. So some of the questions that you've heard in a lot of your calls is, what initiatives do you have planned for your organization? What is your current cloud strategy? So on and so forth. How often do these things come up in your current calls?
Almost, I would say every call.
Yeah.
Yeah, it's like one of the first or second questions that Sal's always going in on.
Yeah, exactly. What are some of the ones that you've seen most effective in terms of pitching to GitLab value?
I do feel like initiatives is one of the more effective ones because there's initiatives regardless of level, like someone who is an individual contributor also has initiatives, as does someone who's a C-suite. So that one sort of hits on each person. Something like cloud strategy isn't necessarily a question you can ask everyone, because someone who's a lower level like engineer isn't really gonna care or know that type of information. So yeah, I feel like initiatives is so broad that it like captures a lot of people.
Yeah. I think that the big thing that we can do here is to find out what they're trying to do and ultimately to show how GitLab can solve their problems. And then all of a sudden, as opposed to a conversation about, well, Jira does this, do you do this? Now we can talk about how it can be a long-term partner, allowing them to drive strategic value. All right, so let's dive into how GitLab can help. So the number one big transition that businesses are facing from a tech perspective is cloud migrations. This is something that I was talking to one of my counterparts who used to work for AWS, and it was really not uncommon that their sales team there would sign multi-billion-dollar deals. So we're talking about the $2 to $3 billion deal range. It was something that happened every week for them. And the reason why so much money is coming into cloud is because it really is strategically changing how tech works in our space. So before we dive into cloud, it's really important to just do a brief review and talking about the fact that 20 years ago, you had all of your own servers. If you wanted to expand out your website, you bought more servers. And the big problem with that is now it's a long process to get all of this upgraded, right? So it's maybe $100,000 investment. It goes through procurement. All the hardware shows up at your data center. Then your engineers, they basically spend maybe a month racking all the servers, installing your stuff on it, finally putting it into production. And contrast that with what we have today, where we have these large public data centers where you can just rent a server from anywhere in this data center. So as opposed to having to go through procurement, signing a bunch of papers, having to select a vendor, doing it all yourself, I can now pay someone 12 cents per hour to rent one of their servers in some combined shared facility. That ultimately is what all of these large public clouds are doing. And where we see the industry moving right now is to hybrid cloud environments with multi-cloud deployments. Let me talk about what this means. People want to be on multiple public clouds because they're afraid of, if we put 100% of all of our stuff on one of them, if they basically jack up prices, then we're locked into this one major public cloud. So for large banks and for especially in the enterprise space, what you'll typically see is that maybe 70% of all their stuff would be on AWS, 20% would be on Azure, and maybe some of their developmental stuff would be on a GCP. But they do that on purpose to spread it out among multiple different clouds and from a business strategy perspective. So businesses around the world, what they're doing is, as opposed to investing in all of their own infrastructure, what they're doing is they're just moving all of those workloads into the public cloud. This is something that I'd say probably 50% of customers are actively doing right now. That being said, some workloads have to run on-prem. So when in your customer calls, what are some of the reasons that customers have given you as to why they need to keep something like GitLab on-prem?
Security is like the number one like concern over security, data privacy. If it's like a healthcare institute or government agency, those are some of the reasons.
Absolutely. One thing to note about this is that that's going to decrease in time because the US public government just signed over $10 billion deal with Microsoft Azure. And so the US government signaled in that is that we trust Microsoft so much with our most important defense workloads. I think that other people are going to start following suit as well. Okay, so the other reason why people are moving to the public cloud is for this thing called autoscale. Is that something that has come up in your conversations a bit?
No, I actually just wrote down that as a question. I've never heard of that.
Okay, we'll talk about what that means, and let's talk about how, one, this is accelerating, and two, just like dive into a little bit more about what this is about. So we basically talked a little bit about how before, if my business wanted to expand our server fleet, you have to go select a vendor, you have to go through procurement. Procurement basically has to sign a bunch of paperwork. Finally, your hardware comes down. Now you basically need to get your own engineers to rack it and then finally install your applications on that. The problem with that is that might take 3 to 4 months. In today's world, that's too slow. If someone can basically go on the internet and get more servers, then they're going to basically be able to move faster than you. It's going to be a strategic driver of their business. And so I just want to show a little bit about how fast this really is. So this is my AWS account. If I'm going to go into the launch instance page, what I see over here is what type of server do you want? If you want Linux server, that's fine. If you want Mac OS, that's fine. So let's just pick Red Hat. Then how much hardware do you want in this server? All of these different servers have different configurations, and you actually have to pay more money if you want more hardware. So some of these are about 8 cents per hour. The most expensive ones are around 50 cents per hour that I've seen. So let's just select something right over here. Let's just say I want to scale up real quick. I want 100 new servers. So over here is basically some configuration stuff. And if I hit this launch button right here, then within 3 minutes, I would have 100 new servers that I can now load up into my fleet. So the business that can do this is going to be able to move faster. That's part of the reason why people are moving in the cloud. The second,
Is that process pretty similar, like across vendors? Like, is it that easy on each of them, or is that just something that's relevant to AWS?
Yeah, so all of the public cloud vendors, they're in part of their strategy is they want to have the most streamlined and easy to understand purchase experience, because if it's too complicated, they lose sales, right? So every single one that I've used, they're pretty simple in general. And the whole goal is to make it as simple as possible. All right, so let's talk about 2 of the other strategic drivers for the cloud. So number one is, I don't want to say cost savings, but it's part of it. But let's just say that you are you're Walmart, right? And the x-axis over here is what time of the year it is. So January, February, June, July, November, December. And then the y-axis here is the amount of servers that you need. So during January and February, there's a lot of people at home, so they're buying a lot of stuff. But once the summer hits, people are going outside. But then back to school hits, there's a huge spike around August. And then towards Christmas, there's a huge spike over here too. So the big problem is that if you had all of your own servers, then you need to get capacity for this level. They know that traditionally they have this amount of load that they need for the holiday months, and they need to build in some buffer in case their projections are wrong. So this is maybe an extra 20% buffer. The big problem, however, is that all of this area over here is wasted in idle capacity. So this is servers that are sitting around in your data center, not doing anything, that could basically, it's basically cost that you're not utilizing at all. So what businesses can do now is they can get more intelligent with it and say, let's get this amount of capacity. This amount of capacity is going to be in our own internal data centers. For the rest, for only this time of the year, this time of the year, and this time of the year, let's rent from a public cloud, ultimately allowing us to save money. So that's what we call the holiday demands problem. The other, can I help clarify anything about this chart? I'm going to move into the other strategic driver for cloud.
Makes sense. This is a really great graph. I didn't know that is something that companies do.
Yeah.
Yeah, really interesting.
For sure.
What did you say it was called?
It's called the holiday demands problem.
Holiday demands problem. Okay.
So the other reason why people are moving to the cloud is for what we call elasticity. And from a technical perspective, the engineers will call it auto scale. So what we're talking about here is if I'm designing an application on the public cloud, then I can make it so that it is smart enough where if more people are visiting our website, it's smart enough to basically talk to the public cloud on its own and get more servers completely on its own. And then once 1 a.m., 2 a.m. hits where no one's visiting my website anymore, it will actually scale down on its own without any human intervention. So you're basically paying for exactly what you use. I'll give you an example of this. This is a Nike flash sale. So let's just say that this is noontime. This is midnight. What a Nike flash sale is they do this thing for like Jordan brand shoes. It's basically a sale for, let's just say like 10,000 of this really rare model of Jordan brand shoes at like a really nice price point. And then so here's our web traffic for Nike. So no one's visiting it in the morning. People are checking it at lunch. People find out about the flash sale on Reddit and social media. And then the flash sale is at 8 p.m. And then it basically just skyrockets. And then it runs at a capacity. So they run at an inventory. And then people are disappointed for like the next couple of hours before social media says that it's out, and then it goes back to normal. So when you design an application to auto scale, it's smart enough so that when all of your workloads are running in the public cloud, you're only paying for what you need. It's smart enough so that your application senses, hey, a lot of people are hitting up my website right now. Let's scale up in AWS. And then once people start, demand starts going down, it starts scaling down completely by itself. If you have an application that has auto scale implemented, then you don't need some sort of engineer in the background going around and then switching stuff around. That's the big advantage. So now just think about this from a business perspective. If you're a business that doesn't have this, then your website's going to become super, super, super laggy until your engineer can basically keep up with demand. If it's done in an automated fashion, then it's going to be a better streamlined experience for your customers.
So is autoscale something that you pay for, like with one of these cloud providers, or is it something that your like engineering team has to enable themselves?
It's a combination of, so the public clouds want to make their service the best, and they want all of the workloads. So AWS's auto scale capability is free. So basically, the idea is that we have to have the best auto scale offering, therefore we can get the workloads, and therefore people are paying for our cloud servers now. We have all the workloads. So what I've seen in general is that auto scale capabilities is free, but if you really want to take it to the next level, then it's going to be a combination of the built-in auto scale capabilities in the public cloud, in addition to logic in your applications themselves. Once you have some sort of layer where your applications has implemented auto scale and the cloud vendor knows how to auto scale on its own, that's when you have like a home run solution.
That makes sense. Thank you.
For sure. All right, so let's talk about some of the cloud benefits and challenges. So one, you can move faster. A business that has the public cloud can basically scale up. Let's just say they can, in our day and age, especially in the tech industry, like your ability to basically update your website quickly, that's going to be huge, especially if you're an A or B round company. So it's especially important for small and medium businesses. Application scale or elasticity, so paying for exactly what you're using, and then also the fact that you can basically have a more robust web service. So if you think about something like Netflix, Netflix has to remain very, very, very streamlined and performing. If Netflix is really laggy, then their customers are going to go to YouTube or Hulu or something like that. And so application scale is really, really, really important driver for many like video and like media businesses. So some of the challenges for this, it's a huge shift in terms of how engineers think about this. You have to hire new people who understand the cloud, who know how to architect software for the cloud. It's not just like a copy and paste type of thing. You have to basically rewrite some of your applications. And the other challenge is maintaining what we call vendor agnosticism. So there's this perception in the tech world right now that eventually Amazon's going to crush everyone else and then they're going to price surge, which is basically like what a lot of people think is going to happen. So a lot of these businesses don't want to put themselves in a position where if Amazon actually does price surge, then they're completely 100% locked into Amazon and then they're stuck with them until they can migrate off somewhere else. So maintaining almost like a Switzerland approach for these public clouds is what a lot of these larger enterprises want to do. That being said, there's usually one main public cloud, and then there's usually a couple of more minor public clouds that they still want to have some workloads on. So let's talk about how we can help with public cloud deployments. So review of GitLab is that people create issues on it, then eventually developers, they code, they submit a merge request. But what we actually do doesn't stop with our CI. The great thing about GitLab is that we can deploy to production, and regardless of wherever that production is, so if it's an AWS Lambda, if it's in GKE, if it's in Microsoft Azure, then we can deploy their workload to that target. And so what we actually bring to the table is one, we lower the barrier of entry for cloud adoption with GitLab. And so what I mean by that is just imagine someone who's starting out in cloud. They're going into the UI, they're clicking launch instance. Every time they want to go update one of their websites and stuff, they go in, do everything to the UI. That takes a bunch of time. They have some engineer who's doing it. Versus if GitLab's doing all of this stuff in an automated fashion. So every single time a change comes through, then GitLab's smart enough to redeploy your applications in the public cloud. So all of a sudden, that just basically just makes it so that your engineers don't have to worry about as much parts with the system. The other thing is how to more efficiently utilize cloud spend by using GitLab to do automated deploys, right? So this is the power of automation right here. Once again, let's just say your engineers are wanting to go update their website. So what they do is they go into the instances section, they find out all of these ones that are old. Then what they have to do is they have to kill them, right? So they're going to go to terminate the instance. And then what they need to do is to remember that they killed 3 instances. And then they want to go launch in a replacement 3 instances. All of this stuff is super manual, super time consuming. If someone forgets something, then it's going to result in a really big problem for the business. If everything's automated, it basically just makes it so that you're more efficiently utilizing your cloud spend. And once again, for these large enterprises, they're typically spending a Bank of America, a Wells Fargo, they're spending north of $1 billion on these cloud contracts. So the ability to automate this and to make it more efficient is talking about more effectively utilizing your expense, maybe 10, 20, 30%. So it's a huge difference and a value driver for these businesses. Last reason is that we reduce vendor lock-in because of the fact that GitLab supports all of the clouds, regardless of if you use IBM Cloud, GKE, AWS, GitLab has support for all of these clouds. Yeah, does vendor lock-in ever come up in any of your customer conversations?
Not really. I'm sure it would if it was like in the PNW. But yeah, I haven't run into it a bunch.
Gotcha. Were you surprised at the dollar figure of some of this cloud spend?
Not really, because Splunk, just from being at Splunk, they spent so much on it. And I remember when we transitioned over to AWS, and like, I think I saw some of the dollar amounts, and it was like over $20 a minute or something.
Yeah.
So, and that was just for like our team, which was like just over 100 people. So yeah, I guess not surprised, but it is pretty crazy.
Yeah. All right, so now let's talk about adopting automation. How often does automation come up in your conversations?
Quite a bit with like organizations that are further along, but a lot of times I feel like it is smaller orgs that are like going for automation, because a lot of these like bigger enterprises have all these like massive tools, and they're just focused on getting on like one streamlined system instead of like automating.
Yeah,
But yeah, I feel like the customers that are smaller and have an opportunity to adopt something like streamlined earlier are like more focused on automation.
yeah, for sure. So benefits, a lot of this is going to be pretty straightforward. You can move faster. Um, so when we're talking about Netflix, who's redeploying like several times per day, you basically need automation. There's no way that you can do this without automation. It allows you to relocate engineers to higher level tasks. What I've seen in general is that all of the higher performing businesses, they have a ton of automation. So a lot of their different processes completely automated. Other reasons why automation is good is because you're more scalable. And what I mean by that is, let's just say that you need to redeploy all of your web servers, right? So that might take someone doing it by hand, maybe a couple of months. But if I have a script to do it, maybe I just need to rerun that script 3 times. One for North America web servers, one for European-based web servers, and then one for your Japanese web servers, right? So it allows you to scale things pretty quickly from a work perspective. Last reason why is reducing human error. So every time I go do something using a UI, if someone interrupts me and I forget something, then all of a sudden, then like I could make a mistake. Versus like if we really have things automated down to a T, then there's just less room for error in general. So having talked with like hundreds of customers the last couple of years, the vast majority of them are in some place in their automation journey. They all know that they want more automation, but the big challenge is, how do they get better automation and how can they unify automation. So things that I heard a lot is, hey, we have a Jenkins server, we have some Ansible and Terraform scripts, some PowerShell scripts. The problem is that some of them are in Jenkins, some of the Ansible scripts are just living in some of this other place, and there's no like unified platform for automation. The big problem with that is that it basically just becomes a big jumbled mess. And especially if one company is acquiring a bunch of other companies, then we have all of our automation, they have their own automation, and nothing is aligned, right? So some people have really, really great centralized systems for automation. Some of them don't have anything. If they don't have anything, then they say that they're doing things manually. And every single person that I've ever talked to isn't happy with the fact that they're doing things manually. So what we bring to the table is that we bring tons and tons and tons of automation to help your developers develop more efficiently. So over here, this is just a screenshot of what GitLab does for its own internal projects. But let me just talk to you about some of the time savings that this stuff is doing. In this prepare stage, this might take me 30 minutes. In the build images stage, this might take me maybe 5 minutes. In the test stage, this probably takes me in general several, maybe an hour, 2 hours. So if someone were doing this by hand, it saves me maybe 5 to 10 hours every single time. But when you're paying engineers to do this and they only have 40 hours a week, we're talking about saving them maybe 10, 20% of everything that they do. And now they can focus on something that's more important. Ultimately, what we do in terms of automation is we help you to maximize your automation with GitLab CI-CD. And so what we're talking about streamlining the utilization of your automation. So over here in this CI/CD pipeline, some of these could actually be automated scripts. So over here in the deploy section, this could be your Ansible script. In the prepare section, this could be like a bash script. So we can actually allow you to leverage the stuff that you've already written, combine it as a universal system with GitLab, and now GitLab is automating the utilization and the execution of your automation in general. So once again, GitLab can be that unifying system that automates the automation that you're already using. It brings you all of this automated, and some of these stages could be the stuff that you've already written. And ultimately, what this allows you to do is when you have a streamlined system, you're getting more out of the stuff that you've already written. You don't have to go remember to execute your Ansible script. You don't have to remember to go like execute some of the other stuff that you've written. And that also reduces human error, right? So in general, we're talking about all of this business value for automation, ultimately saving businesses time, money, allowing them to move more quickly. What we do is we allow them to, one, become more efficient at their automation utilization, and two, we give you a bunch of automation right out of the get-go. So there's this thing called auto DevOps. It gives you a good chunk of all this stuff automatically. So you don't have to write the job. You don't have to have a bunch of engineers write something in Ansible to go kick off all this stuff. We basically had this one team that said, we understand that this is a common customer journey. Let's just create a path so that using all of this stuff is super, super easy. You don't have to write the job itself. And that ultimately saves customers even more time.
Is auto DevOps built for complex use cases, or is it built for just like standard workflows?
It's built for standard workflows. Not everything, there's no like one size fits all policy for all of our customers, but we basically made it so that we want it to have use for 80% of all of our customers.
Gotcha. And can you modify it to like, can you customize it in any way, or does it have to be like what it is preset?
I'm actually not sure how customizable it is. So let me get back to you with that answer to that question. Thanks for asking it. Anything else over here strike out to you, or can I help clarify anything here?
No, I think it's great. It ties in nicely to like the same values that that cloud providers are driving with automation. And so I think it's a good thing that you could tie how GitLab, also has this value of automation, how you could tie that in with your cloud provider as well.
Yeah,
So I think
and
it fits nicely.
yeah, cloud providers want to have a lot of automation in their systems running behind the scenes so that their platform is the easiest to use. Basically, if they can make their platform like have the most business value and make it easiest for all these engineers who are using it, then they're going to get more workloads basically. So a lot of times there's actually automation running behind the scenes that engineers don't even know about. You never see it, but that's what's powering a lot of the public clouds behind the scenes.
Yeah, it's a good thing that the like automation values align, because when like GCP and AWS reps are selling their cloud services and honing in on that, I feel like it'll be easier to tie in GitLab, because they're like, hey, this is another product has the same value system as us that can improve you even further. And I feel like that helps with that partner sale.
Yeah, I completely agree. All right, let's talk about infrastructure as code now. So in the beginning, we talked about how 30 years ago, you had all of your own hardware, you racked your own hardware. Some guy literally had to like plug in a bunch of cables, connect all this other stuff, screw a bunch of stuff in. But let's take a look at the thing on the right. What do you think that this is?
A script.
Yeah, but what is it doing?
Creating a new server.
That's exactly it. So over here, we need to say, okay, what kind of server? Big one, small one. So that's instance type. We want to know, is this server going to be in New York? Is it going to be in Atlanta, China, right? So that's region, and other things like that. So this is infrastructure as code. The whole idea is I'm going to go write some file that basically determines the servers that I want in my environment. So if I want to now have 10 of these servers, I can just run this script 10 times. And now all of a sudden, I don't have to go to the UI to click a bunch of buttons. It's more automated. So that's what infrastructure as code ultimately is. So one of the things that's pretty important is that we talk about GitOps a lot. It's really important to understand what this actually is and how to use it. Otherwise, we're just not going to sound good in our customer conversations. So let me just talk about how widely used the market term GitOps is. If I type in infrastructure as code, there's 500 million results. If I type in GitOps, there's less than 1% of that. So we're talking about literally 5 million down to less than 500,000. So that is less than 1/10 of a percent of the search results. So that being said, what is GitOps? GitOps is basically an opinionated version of infrastructure as code. The reason why we market it so much is that because if it catches on, then this is really good for GitLab. That being said, the vast majority of people don't know what GitOps is, and a lot of people don't like it. So it's important to really take a step back and understand, hey, if I'm going in these customer conversations, let's talk about infrastructure as code. This is something that everyone knows about. Many people are already trying to do this. If I want to take the customer conversation further because they're really interested in it, let's introduce them as GitOps. So they probably don't know what that is. Now we seem like a knowledgeable expert. We're bringing something new to the table. But that being said, the vast majority of people out there in industry right now do not know what GitOps is, and a lot of people don't even agree with it. So let's talk about infrastructure as code and what we bring to the table. So number one, faster deployments. If I want to go spin up like 10 servers, then I can just write my script, run it 10 times. This especially matters at scale because if, let's just say that like I want to go, I have an organization of like 200 different operations people. some of them are going to be new, right? They're not going to know how to go through the UI of AWS and figure all this stuff out. That being said, if I gave them a script and all I have to do is run the script, I've now allowed them to do something really easily that otherwise they'd have to go and figure out. So we're talking about faster deployments. We're talking about lowering the barrier of entry for some of these systems. We're also talking about creating greater security with standardized deployments. So let's talk about why that's the case. In a traditional data center, the big problem is that if you're a big enterprise company, you have a ton of your own workloads, but you also have maybe 10, 20, 50,000 servers that came in through all the acquisitions that you had. And the big problem is that, let's just say that like we have one standard security policy for all of our own servers. Now that we acquired all these new companies, we may not even know if these other companies have security policies. They all have different security policies as well. And so let's just say that we spent 5 months really coming up with a great security policy for our Linux servers, but this new customer uses only Windows servers and we don't have anything over there. So what we can allow people to do with infrastructure as code is that when they define this infrastructure, they can build in their security policy into this and now tell everyone, use this template when you're making a new server because we already hardened it. We know that it's secure. So just use this template. And now everything's standardized across your organization. So now let's talk about some of the benefits that we bring in. So one, version control for your infrastructure as code, and then the ability to perform GitOps easily with GitLab CI-CD. So let me just show you a little bit about what I mean by this. So this is some infrastructure as code that's on the GitLab system. Over here, I can descend in. This is infrastructure as code for defining a Windows server with Ansible. And if I go into this history section, then I can now figure out, okay, like servers were running great, they were running great, but then they stopped working October 12th. Well, now let's see what are the changes that we made in October 12th. Well, the change was this. They added in this thing. So maybe this is where the problem came from, right? So the fact that we give history for your infrastructure as code allows you to better diagnose and audit the problems that you have in your organization. It's basically just another way of making sure that everything that you're running is safe. Otherwise, people could just go out and do whatever they want, which is a very dangerous place to be.
Is that history only something that GitLab does, or do other service providers do that as well? Because that seems like a pretty unique, or I mean, it seems like a really valuable thing, not unique.
Yeah. So version control is something that's built into Git. So any sort of Git-based system like GitHub and Bitbucket, they're going to have that too. So the value driver that I just mentioned there is something that our competitors have as well. But the whole idea is you have a lot of automation as opposed to it living all over the place, could be living on this guy's computer, could be living in some cloud server, could be living on GitHub. Then let's just consolidate it into one place. If you consolidate it into GitLab, and GitLab is basically the trigger for all of your automation, then now one, it's centralized accountability. We know when someone's made a change. And two, GitLab can streamline the utilization of your automation and provide that overlying layer using GitLab CI-CD where you're making the most out of what you've already written now. All right, awesome. How often are your customers talking about Docker, Kubernetes, containers, and stuff like that?
Kubernetes a lot, and it's mostly like inbound requests, like specific to it, like, hey, I want to learn more about how you work with Kubernetes.
Yeah.
And then there'll be like a very specific conversation with the SA and that person. That's pretty much the extent for me. I do know that it's definitely something that essays touched on, because it seems like we have that native integration with Kubernetes, I think. So that's something that they definitely harp on.
Yeah. Do you know why businesses are moving to Kubernetes?
Throw out a guess, maybe it's more scalable or it's more efficient.
They can
Like you
save a
can
ton
make,
of money.
yeah, okay.
Yeah, that's exactly right. So let me talk a little bit about why that's the case and how we can help. So let's just talk about containers and microservices. There's a bunch of terms here. So I'm just going to talk about what these things actually mean. For all intensive purposes, containers and microservices are the same thing. So whenever you hear container, you can think microservice. It's basically the same thing. So other things is a container or a microservice is like basically like a way of doing things, like DevOps, right? But now you need some tools to do DevOps, like GitLab. So the tools for doing containers is mostly Docker and Kubernetes. The difference is that if you want one computer running containers, then that's what Docker is. If you want 500 machines running containers, then you need some sort of management layer that basically says, okay, well, this container lives on server one, this container lives on server two, so on and so forth. And that management layer is what Kubernetes is. So it determines things like scaling and things like making sure that the entire cluster is happy and is working as expected. The other term that I want to talk about is what we call monolith. And so when you hear the word monolith, just think that's the way that all of the old stuff used to be done. So any sort of web application that was written 10 years ago, that's a monolith. Microservices is the new way of doing things. And that's when businesses can save a lot of money. So I'm going to talk a little bit about the difference between monoliths and microservices and why they help businesses save money. So basically, the way to think about it is that for an application that's written as a monolith, then it basically includes everything all in one. For a microservice, you basically split everything out. And now let me give you an analogy to sort of explain like basically how this actually works. So let's just say that you and I needed to print 10,000 pages because we need to make a bunch of workbooks, right? So here's my computer workstation. If I told this one printer to print 10,000 pages, this would take several days. So one thing that you could do is you could get 50 of these workstations. The problem with that is that you don't really need 50 of these workstations. That's 49 keyboards that you don't need, 49 monitors that you don't need. Really what you need is one workstation with 50 printers, which is exactly what we have here. So what we have done with microservices is that we have allowed every single individual chunk of your application to scale individually, as opposed to having to scale the entire thing, which basically results in redundant like stuff that's being scaled. You can now scale out your individual component. So let me just give you like an actual technical example. Let's just say that we have some big website, and what our data analytics team is doing is that it's running all sorts of different like searches and stuff on the website to come up with all the data to scrape it off, right? So what I want to scale is everything that's related to the parts that it's scraping off, but I don't really care about certain other parts that aren't being utilized, right? So the database is probably heavily being used right now. Things that are endpoints that it's scraping off are heavily being utilized right now. But all of the regular stuff like the welcome screen, the stuff that they're not scraping off isn't being utilized at all. So why don't we just scale out the stuff that they're actually doing and are interacting with? So at a high level, once again, monolith, if you need to replicate it, you have to replicate the entire thing. With a microservice, you can now replicate your individual piece or business function. And it's the same thing as us trying to replicate this workstation 50 times. That's 49 printers we don't need, 49 mouse we don't need, to now just having one workstation with 50 printers, which is ultimately way more efficient. So that's the reason why businesses are moving to microservices, is that that's the technology that allows you to scale your individual component that is actually in demand. So that's one piece of the tape of the puzzle, which is cost savings. We're talking about very significant cost savings. If you think about something like Netflix or something like YouTube, then a huge chunk of your cost is all the servers that you're running. If you can make that 20–30% more efficient, then you have a huge advantage over your competitors over a 3 to 5 year time horizon. And so that's one of the reasons why people are going to containers. The other reason why people are going to containers is the fact that they scale way faster than traditional architecture. And so let's just say that this is a scaling virtual machine. So right now, it starts out, we have 3 VMs, and this is an auto scaling application. More people are hitting our website around 10 a.m., so we're scaling up. And then people are getting off of it until 1 p.m., right? So it's scaling back down. So if you have really, really jagged lines like this, then that basically means that because it takes so long to scale, I'll just give you an example. It takes about 3 to 5 minutes for a traditional application to scale. So if a lot of people are hitting your website all at once, like you have a Nike flash sale, then that's going to be a really poor user experience. It's going to be really slow, and people are going to lose interest, right? So contrast that with a container. If you had a container, then you could scale like this, where it's way, way, way more granular. If more businesses, people are coming into if more people are visiting our website, then it can scale extremely quickly. All that matters for a customer because that's going to allow that website to be more robust and be more fast, especially for a dynamic like utilization rate. Can I help clarify anything with this? I know that this is pretty complicated.
No, it makes sense.
Okay, great. Thank you.
Yeah, I think the analogy really helped, like the printer analogy.
Yeah, for
because
sure.
that gave me a really good like baseline understanding of like, oh, okay, this actually, like this is what it is from like a 50,000 foot level, and then I felt like it really helped them to dig further deep. So
Yeah,
yeah,
cool. Awesome. So let's talk about some of the benefits of containers and some of the challenges. One, you save a ton of money in terms of the servers that you have. So let's just say that it costs $10 million to run all of your applications if they're run the traditional way. If we moved everything containers, maybe it would cost us $5 million. We have now maybe 50% cost savings. I'm kind of making this number up, but it is significant. And now I can have a lot of money that I can play around with and do something else that's going to drive value for our business. Two, if you're using containers, then you have more reliable applications because of the fact that they scale better. And so what we're talking about is Netflix guarantee you 100% that Netflix uses containers. Google uses containers. All of the best web applications today, they use containers, especially the ones that are massive for huge enterprises, especially in the tech space. So some of the challenges with adopting containers is that it's a really large technical challenge. You have to basically break down your applications, rewrite a lot of the logic. You have to hire people that understand how to do this, that aren't going to screw it up. There's a huge skill talent gap for hiring these engineers, and you need tools, right? So it's basically a brave new world. People are getting started in this way of doing things right now. There are some people that have been extraordinarily successful at it. 70% of the market is still trying to figure it out, and some of them are really getting stuck because it's hard to do this. And so it's important to understand that right now, container adoption is minimal, but this is going to become more and more popular. Every single business in the tech industry right now wants containers, probably has some project adopting containers, but 80 to 90% of their workloads aren't written for containers yet, simply because they don't have the time to update their systems, but it's something that they want to do. This is actually really good for GitLab because GitLab was written for containers. As more businesses start using containers, we're going to be able to drive more value for these people. What does GitLab bring to the table? One, we make it easier for companies to get into microservices because we offer so many of the tools that they need to do this. So we include container storage. So that's what our Docker registry, that basically is like a storage facility for containers and container save files. Other things that we do is we'll monitor your Kubernetes applications. So if you have some sort of application that's running in Kubernetes, then we'll give you that real-time performance log of what percent of capacity are you at? Are you at 20% capacity, 80% capacity, 50% capacity? We do all of that stuff for you. So the whole value add is that GitLab is built for containers. GitLab SaaS literally runs on Kubernetes. And so this is something that we know really well. Around 20 to 30% of all of our product functionality only works for containers right now. So other things is that some of our deployment methodologies, so like rolling deployments, stuff like that, that is best for Kubernetes. We are really, really great if you are thinking about investing in Kubernetes and containers. All right, can I help clarify anything about containers before we wrap everything up?
You know, if we have a place in Salesforce that tracks who's leveraging GitLab in association with Kubernetes, so like if I was a SAL, I could go and find like a specific customer who is actually using us for that reason or migrated to us for that reason. And maybe this is just like, I could go pull a case study and find that out. I'm sure I could.
Yeah.
I was just curious if there's like a box for that.
I doubt it. I really highly doubt it.
Because it would be interesting to track over time how that's sort of caught on.
Yeah. I will say that in the last 3 years, when I was selling 3 years ago, like Kubernetes is something that half of people had heard about. Now, in every single customer call that I've been on, like basically Kubernetes, everyone knows what Kubernetes is, and now people are trying it. And some of them are successful with it, some of them aren't, but that's only going to increase in time.
Mm-hmm. Yeah, I went to KubeCon, like, what was it, 3 years ago? And it was huge. So I'm sure, like, I mean, I can't imagine how much it's grown since then, even. So, yeah. Is there a, because Kubernetes is owned by Google, right?
Yeah.
Or developed by them. Is it?
It was
something
developed by GitLab, by Google, and then Google decided to make it open source.
Okay, so that's good to know.
It's really kind of bizarre that they did that. Like they could have made a lot of money off of Kubernetes, but they decided to open source it.
Yeah, I wonder why. Like, what was the thought process behind that? Because it seems like it would have been something really unique to add to like GCP.
Yeah.
One of their like huge things. I could see a lot of customers going their way because of that.
So just some questions to ask. Once again, these are really great universal questions that we could ask any customer. And the reason why is because basically every single business, probably 95% of businesses today, they are migrating to the cloud. 95% of businesses are leveraging automation. Every single person that I've ever spoken to, they want to leverage automation more. And then so when we can talk about, hey, we can maximize the automation that you already have and let you get more out of it, this is something that basically everyone wants, right? And other things like microservices, it's another huge driver. And the whole idea over here is these are things that businesses are already doing. These are really complicated things that take around 3 to 5 years to do, but businesses want to do them quickly and GitLab can help. So some of the questions that we can ask is, what are you currently doing for cloud? If it's if they're currently adopting it, then you could say, would you like to learn about how you can maximize your cloud investment? If they already have a mature cloud implementation, then they can talk about Would you like to discuss how to adopt vendor agnostic cloud practices and things like that? But the whole idea is asking these questions, asking them about their initiatives, and talking about how GitLab can become a strategic driver so that we can help them to solve some of these long-term problems that they have. So let's just wrap everything up. Solution selling is superior for complicated customer scenarios. This is replicated by many, many, many studies. And the thing is that in the technological space, then solution selling is in general the best way to go, simply because these are really complicated initiatives. The 4 initiatives that our customers are currently facing that we have a play in are cloud migrations, automation, infrastructure as a code, and adopting microservices. We can help these customers solve their problems with each of these by telling about some of the capabilities that we have surrounding all of these things. And so when we combine a solution selling approach to some of these common customer problems, we can drive engagement and have better sales results. So that's the presentation today. Thank you.